All right, let's explain. This might answer homework questions too. Both these problems are similar, I think, to some of the homework problems. So, what did you do here, Corinne? Do you want to explain your work?
I am here.
Listen carefully, everybody.
I multiply it by r.
Pay attention.
I know how to do
And then
Thanks, Corinne.
like move everything over to one side, like the r squared is x squared plus y squared, and r cosine squared is x. And
So wait, hold up. Let's put pauses in the middle of your explanation. Everyone good there? On the second line, you're okay with this? Holler if you need some help. That's cool. The second line is cool. Yeah.
Okay. So, since r squared equals x squared plus y squared, and r cosine theta equals x, then I just change those to what?
Yeah. So this is x squared plus y squared. This is. Wait, we don't know yet. This is x though.
Yeah.
Is that okay?
Move the 2x over the other side. And then I squared the whole equation.
I need to square the homework things.
All right. When in doubt, let's look at it in Desmos. Okay, you ready? No, Desmos is beautiful. All right. R equals 3, what's it supposed to be? Minus 2 cosine theta?
Yes. You can type theta as a word.
Where is it? I got one.
Are you ready?
No. Oh, God.
All right, hold up. Let's type in Corinne's equation. X squared plus y squared plus 2x
All of that
squared equals 9x squared plus 9y squared. There were some cool things that happened along the way there like that. How'd you do? How'd you do? Come on now. Come on now. Look at that.
Wait, can you look at
Huh?
how come she could square everything and then that's like equal to another r? Oh, she just squared everything.
R squared is x squared plus y squared.
Oh,
Yeah.
I thought, never mind, I understand.
All right, let's check the second one too while we're at it. What is that? R cosine of theta minus pi over 2
I don't enjoy
equals
not understanding.
2. I think I'm already convinced. Yes. Good job, Annabelle. Good job. Green, orange, right on top of each other. Look at that. Okay, any other comments about the workbook? Some people were still having issues with the work on the first one. No one has issues on the work on the second one? It just requires that you remember your cosine. Well, I guess you didn't use, I was thinking maybe someone, there are a couple different ways you could do it. Did anyone use it doing the cosine difference formula? No? Okay, great. In my last class, that's what some people did, but you can do whatever. It is nice though. Is that one of the identities directly, that cosine of theta minus pi over 2 equals sine theta? It's actually not exactly how we wrote it. Can someone?
Oh, I know.
It was actually pi over 2 minus theta. Do you remember that? Why is it actually okay though? No, I think you're close. Why doesn't it matter though?
Cosine negative theta is cosine theta.
Yeah, cosine of negative theta is the same as cosine of theta, isn't it? Because cosine is even. It actually doesn't matter for cosine whether you have theta minus pi over 2 or pi over 2 minus theta in there.
Is it supposed to be pi over 2 minus theta?
Well, apparently they're the same thing, right? We just said.
No,
But in
like
the
if
when
it was for sine.
yeah, when we did the cofunction identities, we said it's pi over 2 minus theta, right? That's the thing that works for all of the cofunctions. It just so happens that cosine can be written both ways because it's even. Yeah. We just mean like, well, it's not coordinates, but any xy pair, any pair of variables you find that's a solution to that equation would be a rectangular set of coordinates, right? So it implies a set of rectangular. Yeah, it's like a rectangular equation. You can say it either way. I think you know what we mean though, right? All right, we do have a lesson to get to, but Annabelle, last question, quick, go. Because it's even? Yeah. Yeah. All right, those are for tomorrow. Let's talk about graphing some polar things, okay? We've obviously seen some already just because like they've come up, right? And we just decided to graph one just now. But I guess the main focus of today, even though we'll like go into technology to look at what it has to offer to us, is also to like graph these by hand, right? So actually get like some intuition. You know how valuable it is to graph and have a really firm grasp of what it means to graph all of the functions you know and love by hand. It's a very useful thing for you to know and love, right? So the same thing, this is going to help us get like really into polar coordinates and really feel our way in. Even though technology can help us, and I definitely am all about technology, I think we do need to have like a fundamental understanding of like how this is going to look qualitatively too. Yeah, come on in. Welcome. All right, so what I'd like you to do is build a little table just with your group and plot a couple points and just see if you can feel your way into this, right? Even though you've never seen this before. Everyone say hi to our Chinese people. Yeah. Welcome. I know, taking pictures never. All right, so does everyone understand the task, right? So plot out, if you need to build a little table, or if you want to just build it in your mind, that's fine. Or you can split the work at your table. You can each plot a couple points. I just want to like feel our way into this. Okay.
Yeah.
You're asking to do something they've never done before. You're asking to apply.
Right. They've never.
I can't do this.
Yeah, they've never.
Did you teach them anything, or you just asked them to try?
All right. Anyone have some points?
Theta is pi 12, so cosine of 2 theta will be cosine of pi 2. What's cosine of pi 2?
Feel free. Now's a great time to pull this out too if you want it. This is a good time to use it. All right, let's come together. I just need a couple points. All right, anybody have even 1 point? Thank you, guys.
I have when theta equals 0.
Listen, guys. Let's pull together. All right, give me any point on the graph. How about Leo?
I just pulled out the graph sheet.
That's right. Zoe's gonna bail you out here. Theta is 0, R equals 4. 1, 2, 3, 4 right there. Someone agree with her? Anybody? Okay. All right, good. Do you have another one? Leo, I'm going to come back to you too. All right, when you're ready. Give me another one. Yeah, when you're ready. Maki, you got another one? Any other point at all? Anything else? Anyone agree? Can I get like an amen on that? Okay. I'm a little skeptical. Let me think. Pi over 4, 2 times pi over 4 is pi over 2. Cosine of pi over 2 is 0. Yeah, so I think I'm good. Yeah, good. And Leo, you have it? All right. Let's keep heading here. Ian, a volunteer. Yes, good.
When theta is pi over 2, is R equal negative 4, is that right?
When theta is pi over 2, R is negative 4.
Is that right?
I don't know. Okay, Sophie said it's true, so it must be true. Yeah, Ruth. Is what? 4 over root 2? I don't feel like graphing that, but I'm sure you're right. Okay. Pi over 3, 4. Okay. Yeah, whatever he said. Yeah, good. Yeah, Cameron? 3 pi over 4? I think you're right. Thank you, guys. Okay. I'll just put another point right there at the origin. How's that? Yeah.
When you put in pi over 2, so I
Yeah, pi over 4, n3 pi over 4, and maybe all the over 4s, it's at 0. We're starting to like feel the structure of this a little bit, yeah.
Sure. It's going to be that polar flower thing.
I'm not allowed to tell you. Well, Leo has another point though.
When you put in pi,
Yeah.
you get where you get
He's got it.
4.
1, 2, 3, 4. Good. Yeah, now do you feel already what's happening? Maybe like someone else tell me pi over 2. What happens there? Not pi. Excuse me, 3 pi over 2. We need. What do you get there? You get -4 also. So that puts us in this direction. Are you okay with all 4 of these points? So when we're in this direction, we generate this point. When we're in, you feeling this? When we're in this direction, we generate this point. When we're in this direction, we generate this point. And when we're in this direction, we don't generate this point. We generate this point, right? And furthermore, there are times, you said, when we're here, too, at the origin, right? Which makes sense. If you just looked at this, will this ever equal 0? Will 4 cosine of 2 times theta ever equal 0? Of course it will, right? There's a time when that will equal 0. This ranges, doesn't it, between negative and positive 4. Isn't that what this expression does? So of course it'll take on 0 as well. All right, now let's pay very careful attention to the order in which these happened. At 0, we were here. At pi over 4, you said we were here. And then at pi over 2, we were here. And then at 3 pi over 4, we were back home. At pi, we were here. You feeling it? At 5 pi over 4, we were back home. At 3 pi over 2, we were up here. And at 7 pi over 4, we were back home. All right, so let's do it all at once. All right, so it's not just doesn't just look that way, it also feels that way. That's exactly the order in which it happened, didn't it? We said we were going to be here, and then we were going to be here, and then here, and then here, and then here, and then here. I'd invite you to do this on your calculator and watch it actually graph it in, not just this picture, but in that order, too. Okay? I'm not sure that is amazing, but thanks for the compliment. Could have been better, probably. Anyway.
not like if it were.
Let's try the same kind of inquiry on this one right here, okay? Let's just see what happens on this one. You can still plot the last one. I don't have any more to say. You'll see that I'm right on the back. Oh, there is one more thing I should say about the last one. What did we require to have for theta? Theta needs to be between what and what for that? I think we plotted theta equals 0 all the way to 2 pi. Didn't we kind of run through all those values to get this picture? We ranged theta between like 0 and 2 pi, right? Okay. I just wanted to make a note of that. Okay. So let's try this one now. Did you get a picture of that in polar mode on your calculator? For theta, let theta be between 0, theta min, and theta max be 2 pi on your calculator, right? Put it in radian mode, whatever you need to do to make it happen. Well, we haven't done this one yet, have we? All right, so let's try this one here. Don't graph this one yet. Let's, again, try and do this by hand first, okay? So, well, I should ask again, like, how big, let's talk, like, kind of qualitatively. How big is this going to be? It seems like this might be another one of those curves, like a flower, like the last one. What is the maximum and minimum R value? 3 and -3, right? So this is the petals, if you will be like 3 units long. Will R ever be 0? There will be a time, I think, when R is 0, that's for sure. So I guess here's one way in too. The question is, like, we need to find the petals, right? And you could start like plugging in random values if you like and see where they are. We could also just ask the equation, when will U be 3? Right? Isn't that a thing we can ask? Go ahead, figure it out. You tell me what theta value is required to make a petal of length 3. Maybe you also ask your equation, when will you be -3? Because that also corresponds to a petal, doesn't it? We've seen, on the graph, those look exactly the same. Petal of length 3 or -3. So find those two places.
Oh, you actually haven't thought.
Are you not?
No, we are not.
Sometimes I know where you go. He's blind. This is Eric. Okay. So I would like to know what the solutions to these two equations are. When is sine 1, just in general, normally? Like, when do we have it max? Yeah, pi over 2 and, what's the next one, by the way, after that? Not 3 pi over 2, that belongs over here, doesn't it? But what's the next one here? What would we call it? Huh? Yeah, what would that be? I know fractions, right? 7th period, it's hard. Okay. Pi over 2 plus 2 pi, I don't know. Okay. So then what's theta? Okay, see how we might not have guessed this? I don't know.
Wait, how did you get from 1 to sine of 3 theta to that?
Well, if sine of 3 theta, if sine of a thing is 1, then that thing must be pi over 2. Yeah. So we have pi over 6. Looks like we get a length of, in the pi over 6 direction, we get a value for r of 3. Yay. By the way, we think we already are all convinced that we do have a value at some point, at least, of r equals 0, so that's cool. Let's put that on there. What else we got? What's over here? This is 3 pi over, well, no, it's just pi over 2, right? But that's a negative 3. So that's down here, in the pi over 2 direction, but now down here, negative 3, okay. Interesting. We should keep going in these lists, though, shouldn't we? I mean, there are other petals. I guess if you really think about it, if you let theta range infinitely, you get like an infinite number of petals. They might just like land on top of the ones we already have, right? So we do keep having petals. Let's see what happens here. What's this one? 5 pi over 6. We don't have that one yet. Okay. You want to say another one? I don't know. What comes after the 3 pi over 2? What else would that be? Let's add 2 pi to that. Let's see if your fraction work is any stronger than it was a minute ago. All right, so that would be 7 pi over 6 with a length of negative 3. 7 pi over 6 is here, but with a length of negative 3, that puts us back here, doesn't it? So actually, we kind of already have that one, don't we? Would you like to do any more on this list, here or here? You can if you like, but I think you'll find that any other petals you find in these lists will just land on the top of the other 3 we already have. So I think we're done. And I think that it looks like this. And again, I'm graphing it in the proper order too. Okay. Feel free to check on your calculator if you like. Yeah, Franklin?
So wait, is this, that is n?
Yeah, we didn't even read the instructions for top, did we?
Well, no, it's n is I.
Good job.
No, like it says that like the number of petals to n is afterwards, and
What if n is what?
Wait, no, if it was just 1, it would just
How many petals would there be?
1.
Yeah. Right.
Okay.
It'd actually be a circle.
That one's right, yeah.
Yeah.
That's
Okay, I have this example ready to go here. All right, so did you put this in your calculator? I want to watch this happen here. 0 to 2 pi. I have the ball going on this thing. There. Okay, cool. You ready? You go over there and hit that enter until you get the ball. 3 sine 3 theta is the example we just graphed. So let's see this thing in action. Is this what we expected? In the order we expected it? Yeah, cool. Watch carefully. What just happened? Did you see it? On the interval 0 to 2 pi, it looked like what happened? It looked like it went around twice. So in these instructions, and maybe you already noticed this, on the first example, we had 4 petals, and it was like a 2 theta inside there, right?
Yeah.
Here we had, so you might have, after doing that one, you might have thought, oh, we always get twice the number of petals, right?
Nope.
Here, we only got 3 petals, even though it was a 3 theta. Can you, is that what this says up here?
Yeah.
But in some ways, did we get 6 petals? We kind of did. On the interval 0 to 2 pi, we actually did get 6 petals, didn't we? It's just that what happened with the second set of 3 petals?
They overlap.
They just like it just overlapped again. So I guess what I'm saying is we could just do from 0 to pi on this, and you would get a picture of this. Unlike the last one, if you do 0 to pi, you'll only get half of the picture. But here, if we do 0 to pi, you do get this whole picture. It graphs it in only a space of 0 to pi. So yeah, there kind of are, in both cases, 2n petals. It just so happens in the odd case they land on top of each other again, right? So yeah, theta is, here, we can graph this in just a space of 0 to pi. It's actually not like just a curiosity when it comes to like in our calculus course that I'm teaching right now, like we'll calculate the length of one of these, or we'll calculate the area inside of one of these, or something like that in our calculus course. And if you don't know that you need to like make your integral run from 0 to pi instead of from 0 to 2 pi, you'll get like twice the area or twice the length of the curve that you meant to. So these things do come up again in your life. Here's one more interesting question. How would you get only one petal? How about this first petal? Could we put theta limits on our calculator, min and max, so that we would only generate that first petal? It's an interesting question. How would we do that? What's true as we start and stop on a petal? What's the R value? At the beginning of us making a petal and at the end of us making a petal. Yeah, and again, if you want to know when this equals 0, when R is 0, you can actually figure it out. So tell me, when is R going to be 0? What do we need? 3 theta needs to be 0 or pi,
Every pi after that.
etc., right? So theta would need to be 0 or pi on 3 or 2 pi on 3, etc. Okay? So I'm going to do that on my calculator now. I'm going to make it go from 0 to, when do I think the first petal occurs? Yeah, maybe from 0 to pi over 3, and let's just see if we get the first petal. Come on now. Moment of truth. Boom. All right. All right, let's, so those are called Rose curves, and there's like kind of some text above that last one that said some stuff about when that happens. Neat. I kind of don't care a lot about the rules though, as long as we can graph these, right? That's the main thing. So same thing here. Let's graph these two guys, which are, I think you can already tell, are not going to be Rose curves. And then afterward we'll like say what the rules are, and you'll be like, okay, neat. That's like, of course those are the rules. Okay, you'll feel it right away as we graph these. So I want you to do the same thing here. What I recommend on both of these here is that you try the 4 cardinal directions. And I think that'll almost do it for us. So, like on this guy here, what happens when you plug in 0? Or pi over 2, pi or 3 pi over 2. At least graph those 4 points for these, and then we'll talk. Leo, you ready to give me some points this time?
You tried copying both at once.
Yeah, you can have a 4. I mean, it's symmetrical in a couple different ways. You can claim it had like 6 symmetries actually. I guess the question would be like, what's the curve of a sine curve in general? Right? That's not your favorite question. Because they're the same thing, actually. We haven't like made that connection yet. But these are the same. Like, do you remember graphing last semester? Y equals 3 minus 2 sine x. This is just a different way of representing the same equation, actually. Yeah. Plus, I'm asking the same kinds of questions we did last semester. Where do the maxes and mins occur on the last graphs in last semester? Where the maxes and mins occur? Those correspond exactly to the question, where did the petals occur on the graphs you just made, right?
Yep.
What's wrong with
Okay. All right, give me some cardinal directions. Did you get in 0? The 0 direction, did you get 3? And also while we're at it, also in the pi direction, yes? Okay, because this thing in both cases, this whole part here disappears. What about in the pi over 2 direction? 1? Yeah, because you'll have sine of pi over 2 is 1. So 3 minus 2 is what we'll have. That'll be 1. And in the 3 pi over 2 direction, you'll get 5. Good. So, and let me ask you this. Will r ever be 0? We asked that before. I mean, I think you can just, from your first semester knowledge, think about how this thing goes up and down. This is always never outside the range of 3 plus or minus 2, right? Yeah. So, earlier last semester, you might have like drawn 2 channels, right? That this sine wave was going to be in between. You'd be like, okay, its minimum will be 1 and max will be 5. Well, here that corresponds to this like annular region, right? It never goes inside this circle. It never goes outside this circle. Yeah? I think that's what you just said. You said r will never be less than 1, nor will it be greater than 5 ever. So the whole graph should rest inside this region, shouldn't it? Well, I don't have much more to say except to kind of show you what this looks like, kind of, right? It's kind of like the one from that was not that great. It's meant to be symmetrical, but on the warm-up, I think part A, that was one of these guys. Too. Same kind of graph. Go back and look at that if you like, and you'll see. I mean, it was tilted the other way, right? But you saw that graph. You said ooh, I think. Yeah. You actually don't have a great sense for that without a little bit of further analysis, and we're just not going to talk about that. Okay.
Are you going to do like, are we ever going to do like graph, like, ones with depression?
Yeah, I mean, you can just assume. No, you can graph that by hand. Okay. Well, you won't know whether there's a depression yet, so it's okay. Yeah. Graph it on your calculator if you want to confirm that we're right. That is about what it looks like, though. Try it. Okay. All right, let's try this one. Same kind of story. Right? Plug in 4 cardinal directions. If you plug 0 in, what do you get? 6. 1, 2, 3, 4, 5. That's unfortunate. Okay. All right, 6. If you plug in pi over 2 or 3 pi over 2, you get 2. Will this ever take on the value 0, by the way? Will r ever be 0? Think about it carefully. What's the maximum? 6 you just said. What's the minimum? You haven't said it yet, but yeah, it's -2 in the pi direction. In the pi direction, -2 looks like that, yes? Yeah. Just want to make sure everyone's good at graphing polar coordinates. That was why we spent a day playing Battleship. Okay. Does the r value ever equal 0? Let me ask that again. The r value, the maximum is 6, the minimum is -2. Do you have a reason why you think it wouldn't be 0? I think that there will be a time when it's 0, right? I mean, I think it'll take on every value between -2 and +6, won't it? In fact, I think you can even tell me, why don't we do this, because no one seems to believe that this is true. Tell me what theta gives you an r value of 0. Go, right? Like, figure it out.
I don't want to. Okay.
Yeah, you do, right?
Oh, yeah. Oh, wait, no.
It actually works out nicely on this particular problem. What do you get?
2 pi over 3.
2 or 4 pi over 3? All right, so there are actually 2 moments along the interval 0 to 2 pi where it takes on the value 0. So I think we're ready to draw this. Are you ready? At 0, we said it was here.
Oh, nah. What is that?
Right? I think that's about what it looks like. Check it on the calculator. This is not a flower. Yeah. Which should be clear. How do you know whether there's going to be this like inner loop on one of these things? I would put these in the same category. This one doesn't have like an inner loop. This one does. Why? What makes this equation right away before you ever even plot anything? What makes you think that there will be an inner loop?
A is greater than the constant.
A, are you calling this A?
A would be the thing in front of the cosine or sine, and
Or
we're
this,
gonna call
okay.
B the additional number.
All right, so I think I have it on in the opposite way on my other slide. But whatever, if this number here
It's greater than
is bigger than this number here, then won't this happen? Won't we get that inner loop? Why? Explain. I don't know. Someone explain. Why should that happen?
I think I get it.
Someone other than Ian, because I think Ian does get it. Why should there be an inner loop? Why wasn't there an inner loop over here? Why? Oh no. How could you modify, let's ask this question. How could you modify the original equation over here, this one, so that there is an inner loop? Could you make that happen? Huh? Make this a -3? I don't think that'll work actually. We need to have it like cross 0, don't we? So how are we going to make that happen? Make what? Yeah, maybe make this a 4 or something, or make this a 1, or right? Make the second number bigger than the first number. Create the inner loop. Yeah. To make it like a -5 or something.